Which brings us to our last panel today. And for you, as our audience, this means it's the last chance to ask questions, to use our hashtag Quantum Summit 21, and to be engaged in our discussions and our panels. So the last panel of the day has the title, Don't Forget the Users, because we talked a lot about the knowledge and the system behind quantum computing. We had some academic perspectives, and we talked about some sectors that might potentially benefit and are benefiting right now. And last but not least, we want to take a closer look at the users. So what kind of problems can actually be solved? How can we reach new users? And how can we connect users and new technologies? And navigating through these questions will be our last moderator of this Quantum Summit, Felix Schiessl. He's the quantum computing community lead for the DACH region at Accenture. And who would be a better fit than one who helped ramping up Accenture's quantum computing business in the German-speaking market? I'm really happy to have you with us today, Felix. The stage is yours.
Thank you for having me. Hello, everybody. First of all, I want to invite you to ask your questions in the chat and also share your experiences or thoughts with us in the panel via the chat. Now, happy to dive into the discussion on quantum computing users together with great panelists. So we have with us Claudia Pohlink, who is head of future networks, which includes quantum computing and AI in the R&D department of the Deutsche Telekom. Deutsche Telekom is part of the Planck Consortium and also OpenQKD. And they also have their own projects, for example, with Fujitsu. We have also Dimitri van Esch. He is the quantum lead and solution architect at ABN AMRO. He has a background in IT, was CTO of several startups, then turned to project management and business development, and is now looking into future technologies for ABN AMRO. We also have Detlef with us, who is data scientist at the Roche Innovation Center in Basel. He's a computer scientist and is with Roche for over 25 years. His main work is on digital biomarkers and on quantum computing. He's also working, for example, in the chemistry task force. So let's dive right into. And I want to start with a philosophical question, because our talk is called Don't Forget the Users. But who are the users? How do we define them? Maybe we start with your perspective, Claudia. Who are the users for you?
I would say, of course, Deutsche Telekom is a user. So we see that topic, of course, as a user, but we also think in terms of our users. Yeah. So when it comes to quantum safe communication, then of course it is there is the potential that we can also sell this as a business to our customers, and also to keep our customers secure when it comes to the new communication or the new, let's say, era of communication. Yeah. So right now we feel that we are a potential user in the future, and I would say a hard user.
Detlef. You're still on mute.
That's a good question. So there are two perspectives. I'm in a pharma company. So one end user is, say, a patient suffering from leukemia and receiving a monoclonal antibody. Or more where we see quantum computing for now is, for example, in virtual screening, a chemist who wants to select compounds with higher efficiency in shorter time.
So also on the business side. Dimitri, what do you think?
Yeah, thank you for having me here. So I'm glad to be here. Talking about the users, I think, there are different levels of users. So, the first level are, the technology providers. Then the next level are the corporates like ABN AMRO as a user. And then the third level is, within ABN AMRO, we have different kind of users for different kind of technologies. For quantum computing, the user are more, let's say, the data scientists of the different business units. If you look at quantum communication, it's more the security people that are the users. So the chief information security officer, for instance. And then, and going along with Claudia, in the end, our users, who are our users, the real end users, are our customers, that we need to make sure that they can be protected with the rise of the quantum threat.
So we already heard you're looking into quantum security, quantum computing. And I'm wondering, what are you as companies looking into? So, Detlef, what is your focus?
Yeah, so we have 3 areas that we are looking at. One is optimization, the second, machine learning, and the third is chemistry simulation.
Dimitri, are you also focusing on quantum computing or other technologies?
No, the focus is more on quantum communication, I would say. So that's the most important thing, protecting and making sure that the financial networks are secure. And then the same sense also post-quantum crypto is equally important for us. But, in order to understand why you need it, when you need it, what's the right time, how to interpret all kinds of news, you also need to understand what's going on and when this quantum threat will be there. So even if you don't do anything with quantum computing, you need to understand what's happening in that field. So in that sense, we are also exploring to a lesser extent quantum computing, but still we are doing a project in the field of quantum computing to really get our hands dirty and to learn what it does and how we need to interpret that.
Claudia, maybe you can share a little bit with us how your quantum journey started.
Yeah, so it is a bit similar to Dimitri, because so a few colleagues started to investigate in the security area, I think a few years ago. And we at the R&D department, we started 2 years ago with exploring the whole field of quantum computing. And we divide quantum tech in 3 areas. The first one is quantum computing. The second one is quantum communication. And the third one is quantum sensing. Yeah, but we said, okay, let's start at the R&D department with quantum computing. And the last 2 years, we explored together with colleagues optimization cases, but also ML, so machine learning cases. And we realized, okay, we need a bit more time, yeah, because also the hardware is not ready enough for this whole implementation. Yeah, so it's cool to investigate, but later on you have also to implement that stuff. Yeah, and I think we need a bit time yet. So let's say 2 to 5 years, and that's why we refocused this year again on quantum communication, and as Dimitri already mentioned, so QKD, post quantum crypto, and all this stuff, and so. It is so exciting, this field, and you have to be very focused. Yeah, so I would recommend to focus on 2 or 3 projects per year. Yeah, because of course it depends on the team, but it is too much already on the market when it comes to technology, but also when it comes to research paper and to be in every field right state of the art. Yeah.
So maybe that's leading over to another question, which is when companies actually should start exploring quantum technologies and what the timeline is to build up a program and also proficiency to use quantum technologies. Detlef, what do you think?
Yeah, well, we started in 2018, figuring out where could that technology play a role. Yeah, we all know this Shor's algorithm that was mentioned here 100 times, and where one sees an exponential speed up. And we are located within research, so we have good connection to our disease areas. And maybe I forgot to mention before, we focus only on quantum computing because we believe that Telekom will do their job right and provide a secure communication. So. And the bank, of course, also. So we look where is quadratic speed up or exponential speed up possible, and where could this be done? And we soon realized, okay, none of us wants to become a quantum programmer with these gates and matrices and linear algebra and complex numbers. So we are partnering with universities and partnering with companies. And for example, we are getting the first results. Like Claudia said, one must focus. So we focused on these 3 areas chemistry simulation, machine learning, and optimization. And in the optimization thing, we focused then on protein folding. And there actually last week, the first publication together with Tencent was also a quantum laboratory, was put on archive.
So, Dimitri, do you think the time to start is now, or what is the timeline? How long does it take?
Good question. We also started a quantum program in 2018, and it was a little bit management by fear, I must admit. So, you got to bring a little fear into the future. Predicting when will Shor's algorithm, be realized on a 4,000 logical qubit quantum computer, because that's the moment when some RSA key pair can be broken, and every internet connection can be suspicious or not trusted anymore. So in the moment when that happens, we call it internally the quantum apocalypse. It might be the next millennium problem, the time when no one trusts anything anymore. People won't use their mobile banking apps anymore. They'll just run to an ATM machine, empty the bank accounts, because, with the current interest rates, there's no use keeping your money at the bank anyways. So, if that happens worldwide, a couple of weeks and we're all done. Financially, economically, everything is broken. And, the thing is, it doesn't have to really happen. One company only has to make one press release in order to create this complete panic, where other news agencies will come up with these big headlines: the internet is broken by quantum computers, etc. And people will go on social media, and panic will be worldwide. And then when is this going to happen? We've been asking that around, and we've been asking that to several companies, let's say commercially focused quantum startups, but also universities. And it ranges from 5 years till 20 years. So we're saying, okay, let's put it somewhere in between the 10 and 15 years. This could happen. Could be a realistic time. It could be longer, but let's say 10, 15 years. Then you can think like, okay, 10, 15 years, that's a lot of time. So you don't need to do anything now. But what we also did was that we took a look at how much time it took us to perform, let's say, a network upgrade from SHA-1 to SHA-2. And that was, let's say, a regular upgrade. And the upcoming upgrades to post-quantum crypto QKD are not regular upgrades. It's something new. But our previous upgrade took us 12 years. So imagine that you need to implement something new that has to still follow standardization, regulations, and then implementations. It's going to take us at least 15 years. So when is the time to start your quantum projects, especially in the fields of quantum communication? It's right now, and you might already be too late.
Claudia, you were nodding a lot. Do you see
because
like Dimitri?
Yeah, that is so true. Yeah. So this is not only about technology, this is also about knowledge and developing the knowledge. Yeah. So you have to build up this whole new technology, and it takes time, of course. And we all already know the talent war from AI, from artificial intelligence and data science. It's quite hard to get the right experts on board with the right mindset. And here, in that case, you need a combination of an IT expert, data science, because sometimes you need also knowledge in Python and so on, and then physics. So this combination is very rare. So that's why it's also the reason to start right now, because you cannot just start like this, and you have all the knowledge in your department and you know how to do all that stuff, so because you have to investigate in the technology, you have to investigate in the field of research. So you have to read papers, you have to try to understand, and then you have to, of course, to exchange with other players around, so maybe other branches, and how did they start and so on. So it takes time to explore this new key technology, and it will be a new technology, and you have also to shift your mindset when it comes to the physics. So for instance, maybe all your connection or your cables are trying to understand this whole world completely at the opposite. So that's why you also need to change your mindset. So this is nothing what comes overnight. Of course, sometimes it could be also too late yet. So.
Yeah, can I elaborate a little bit on what Claudia said? Because what she's saying is very, very important. It's not just about this technology; it's about your workforce and preparing your workforce. And you don't get to learn and understand quantum technologies in 6 months or via a 2 or 3 day course. It's going to take a lot longer. And people that will say, that it's easy to just, shift to quantum and then use it immediately and it's easy migration. It's not true. It's not going to work like that. It's going to take you years to properly understand and be ready to do the proper implementation. So, and right now, I'm trying to discover what the current workforce will be and what kind of skill sets do I need in my teams. I don't know yet. I'm still working on that. And I'm learning something new every week. So that's really, really important to also grab your head on that.
I think that's quite interesting. So how do you see it in regards to business and IT alignment? So how can we bring together business value, IT skills, and quantum skills? Are there any communication or alignment gaps? Detlef, what do you think?
Yeah, well, well, I'm in a research IT department, and we have the luxury of being not in the IT department, in the main IT, but directly reporting to the head of research, more or less. And so we have direct connections to the biologists who work on the diseases and to the chemists who work on the molecules. And that dialogue is key to getting the things together. So yeah, and in terms of skills, if I see these variational quantum eigensolvers, I think it's necessary to have people who understand how the algorithm really works and where the speedup comes from and where can one optimize. Because the current hardware is so limited, so one has to find the places where can one compromise. And so you need people with really good math skills and the chemistry, and that part too. Yeah.
Dimitri, how is it in finance?
That you have the finance, let's say, skills, you have IT skills, you have data science skills, and then security skills, and then quantum skills. So how do we bring that all together? And like Claudia also mentioned, there's a lot of skills that you need to complete such things. And so far, I haven't seen all of them in a single person. So you need to bring that together, and those different people from different departments talk different languages. And right now, it's even the quantum skills are located mostly at universities, and universities talk different languages than enterprises. So you have to get together and bridge that gap, and then it takes a while, which is fine. You just need to understand it and make sure that you put it in the right place and take care of that. So it's communication, let's say, at human level. That's also very important in this sense.
Claudia, I know you're a great team from the Bitkom, but also from Pohlink. So how do you bring together the business, IT, and quantum people?
Luckily, the board member at Telekom who's responsible for technology and innovation is a physicist. And she is, of course, open for that new technology. And also our CEO, Tim Höttges, he's also already aware of this huge new topic. And I would say also they already see and can imagine the potential and the benefits. Yeah, but of course, this is one level, yeah, but you have 3 levels in a corporate, yeah. You have this top management level, and then you have, of course, the for instance, the R&D department or the security guys and so on, and then you have the middle layer, and this is the hardest part, yeah. So so to convince the middle layer, and here in that case, of course, you can develop use cases and you can prepare that very good, yeah. But then every time you speak to a manager, you have to explain this whole stuff, yeah, and you don't know where to start, yeah. So it's not only about finance knowledge or so the domain knowledge, yeah. From data science, we know domain knowledge, and then security, IT, and so you also need to translate it into a language for the business, yeah. And then it comes to I would say, the hardest part, yeah. So you have to translate that in a way that they can imagine and understand this is not just an evolution, yeah, for the whole computing, it is a revolution, yeah. And then you can come up with examples. For instance, yeah, I always ask the question, imagine there is a table with 10 seats. Tell me how many combinations are possible, yeah. And then it comes to faculty, and somehow they can imagine there is a potential, yeah. But then, of course, it comes to numbers and so on, and then you have to convince a lot, and you have to stay very, hartnäckig in German. I don't know the English word, yeah. So strong.
Great. So you mentioned the business, and I'm wondering if you're aiming to drive the topic and generate like competitive advantages, or do you want to learn how to integrate solutions as the technology matures? I think they're already probably most of the people looking into quantum computing now are early adopters, maybe early majority even, but there's still 2 types of people or of companies getting into the field. Which one are you? Starting with you, Detlef.
Can you again say what the 2 types are? Then it's easier for me as a computer scientist to classify myself.
Sure. The ones who are aiming for competitive advantage by using quantum computing, and the ones who just want to don't be left behind and want to learn how to integrate it in time.
Well, maybe I'm too much on the research side, so I'm not a business person. So it's very clear we want to develop the molecules better and faster. So of course, this is in the end a competitive advantage here. So I don't see such a big difference between the 2 poles. Yeah.
Dimitri, how do you think?
In a sense, it's for competitive advantage, but in another sense, it's not. We didn't start our quantum program to get any competitive advantage. We didn't start our quantum program with, concrete results or return on investments. We started our quantum program to, go from talking to doing, to really get to understand how those things work, so we can properly search for use cases and see how we should or could implement them. And there's a lot in the fields of information security in that sense for us. And the thing is that, there's this gentleman's agreement within the Netherlands between the 3 largest banks that, whenever in the fields of cybersecurity someone is seeing or discovering something, we don't take any competitive position on that. So in that sense, we said, okay, if we can't do that in the fields of cybersecurity, but we still want to start and do something, then what should our position be when some other ING or Rabobank comes along? And the thing is that we said, okay, we're just going to start. We're not going to search for a cooperation right now, but if they want to talk to us later on, it's fine. And if they want to learn from us, it's fine. If they want to work together with us, it's fine. And actually that really happened. So 1 year after we started that program, we started talking to ING and Rabobank, and then we explored how we could work together, but not for this competitive advantage, but more in the line of being and keeping things secure now and in the future. And in the fields of computing, it's not, we don't want to be left behind, obviously, but we don't know if we can really take any competitive advantage in the coming years. I received the question to, can you create a return on investment with one of your quantum projects in 3 years? And I was like, okay, if I say yes, it's going to make my life easier for the next 2.5 years. But at the same time, I realized then after 2.5 years, I'm probably going to have to look for a different job. So I told no. I said no. I'm not going to promise anything within 3 years. So and we don't know yet. It's a big explore. That's why that project is called Discover, to discover what we can do and how we should do it, and not to bring any concrete examples or business cases yet.
Claudia, anything to add?
Yeah, so it would be much easier if you can convince your business or your management, if you can explain them the potential advantage. Yeah, for sure. Yeah, but I think it's not possible yet for nobody. So as Dimitri already mentioned, it is not serious to bring that on a business case level. Yeah, so I would say it is more about exploring in a field where you are convinced this will be the future. So it will not substitute the normal computer world, yeah, but it will be another potential area or world where you can explore much more what we cannot imagine yet right now. Yeah, so and that's that's one of the hardest parts, yeah. So that you cannot really explain that everything is possible, yeah. But how you can come up with a concrete plan or business plan, yeah, for a concrete use case, yeah. You just have all this stuff with combination problems, and then you can also say, okay, we are dealing with our security challenges in the future. Of course, it is our job to secure the communication, and we have to make sure that all our networks are protected against quantum attacks. Yeah, and then you can also build the vision of a quantum internet. Yeah, so in the next, let's say, 10 years. Yeah, and then it comes also to hardware, a quantum repeater, and all that stuff. Yeah, so there are so many opportunities, and I would say it is right now also the European culture is not that the risky culture like the Americans are or the Chinese guys are. So it is not about the advantage, but it is about this, what you mentioned as the second part. Yeah, we have to step on the train. Yeah, and to be not left in the future. Yeah, but also to see the potential. Yeah. And be brave enough to invest in that topic.
Maybe I can add one more thing. I think it's important to explain to management where the advantage can come from, and that idea, at least say in the case of quantum chemistry, I can explain that one can electron orbitals to qubits. And then what Claudia said, yeah, with the, if one adds one more person to the table, one sees how the number of possible combinations explodes. And there it's the same. If one adds one more electron, the number of potential combinations also goes up. But if we can map this to qubits, it becomes somehow more tangible how this goes together. And but I think one needs to make this connection to make it plausible. Yeah, clearly the hardware is not there yet, but I think, like with Shor's algorithm, there's a clear path and it's proven. It brings an advantage. And for the others, I think one also needs to go down to that level and make it plausible where the advantage can come from.
But I would say that some branches are more mature. So I would say chemistry and pharma and finance industry do have already advantages. Yeah, so the telco industry is a bit behind. So that's why it is quite harder for us right now. So I would say you have, let's say, 2 or 3 years advantages already in your area with the papers, with the research. Yeah.
Yeah, I'm just also curious. So what sort of use cases do you have where it's, say, memory bound or so the problems?
So, yeah, for instance, when it comes to optimization, yeah, so it is about network planning, yeah, or network optimization, yeah. So, yeah, just to give you an example, yeah, we call it the frequency assignment planning, yeah. So in the mobile area, yeah. So you have the towers, and then you have the frequencies, and you want to avoid, for instance, interferences. Yeah, so you want to minimize interferences, and of course the maximum number of the frequencies to meet the traffic demand. Yeah, this could be an optimization problem. Yeah, but you have, of course, to compete the classical methods right now. Yeah, so you have to prove that you are better than, let's say, the classical, let's call it machine learning methods. Yeah, so and sometimes you have just to build up the baseline. Mm-hmm. Yeah, and this is the first task, and then you try to develop the same result with quantum tech or digital annealing, for instance. Yeah, it's also possible. Yeah, I think in the talk before, Oliver, my colleague, already explained our example with FREE2, and it was nearly to frequency assignment planning. So yeah, I think I would say it is easier for the finance industry and also for chemistry and pharma, and maybe also automotive. Yeah.
Yeah, thanks for the example. Yeah, that's good.
So I think quite interesting. We will focus a little bit more on the application side later on. But Claudia, you also brought up the topic of stakeholder expectations. So maybe Dimitri, you can share some tips and tricks for the audience on how to manage stakeholders' expectations on outcomes, return on investment, while making sure you get enough visibility and drive onto the topic.
Yeah, that's a difficult question, but definitely the element management by fear is important. So you have to tell them this, this timeline of these 15 years, and then map that towards how much time you will need to fully implement it. And what we also do is, and we said is, what kind of concrete results can you get out of it? So return on investment promises, I wouldn't go there. But what you can do is and I call it, something like a disaster recovery plan. And why do you build these disaster recovery plans? When something happens, at least you have a plan, so you know what to do. So instead of running around in circles with your hands in the air in panic, you know what to do, even though you're still kind of in panic, but you know what to do so you can resolve it better. With these quantum algorithms and quantum computing, it's kind of like the same. So what we're doing is we're trying to find these use cases. We're trying to define how much qubits or hardware, what we need, and how much time it will take us to implement it. And then, then you have kind of like a plan. And then you have to keep monitoring what's going on, and then, predict when you think that time will be there. Take that time away off from the time for the implementation, so you know when to start. So, when that hardware will be available, then that you're ready to do that. So that's what we are saying. And at the same time, it's also, the thing about just making your hands dirty is a very important thing. And I'll give you an example on that. When we started exploring this QKD fields, and I started talking to QTech in Delft, and trying to understand how this entanglement thing works, I thought, we could just send 2 qubits to the other side of the world, and they could, talk to each other and communicate spontaneously without any delay, which is not true. Because when you really dive into it, you learn, to send those qubits to the other side of the world, you need a carrier. And this carrier on fiber has a distance limitation, and this carrier via satellites has an availability and a link budget limitation. So, and those limitations will change what use cases could be really useful or not. So taking that and learning that really it takes you to the point to understand what you can do with it. And at the same time, what happened is that at the end of one of the QKD projects that we did together with ESA, was that we learned something, and then we said, okay, let's take a look at it from a different angle, from, let's say, our angle instead of the quantum angle. And that gave us a real insight. And that insight led to a design of a quantum enhanced protocol. And that design led to a patent that we filed last December. So unexpected, but it happened. And this field of quantum technologies is so green and big that, when you start exploring now and get your hands dirty, you can establish kind of like the same thing. And new things will come up, and you don't know what to expect yet. So that's, don't promise concrete results, get your hands dirty, and you will get something out of it.
Thank you. And I think we talked a lot about internal challenges when introducing quantum computing, but there are also external challenges. And you mentioned, for example, the hardware, that there are some challenges, but there's also a lot of snake oil out there. So how can one avoid falling for snake oil in claims from vendors, service providers, software companies, or just random people on the internet? Detlef, what do you think?
Yeah, thanks. I will come to that immediately, but I like the example of Dimitri very much, and would like to also share one peculiarity of the pharma industry is its sort of risk is very normal in that business. There are so many drugs that first work and are not toxic, and one is so happy, and then one gives it to many patients and it doesn't work anymore. So there's a high attrition along the pipeline. Managers are very used to high risks, and therefore I think it's not so difficult in the pharma industry to try out quantum computing, even if it's not so clear whether it will work, but that's normal. Yeah? And with that, I think we also had more, management by opportunity rather than management by fear. So you see a potential opportunity. And we try to explore now also, like you said, make your hands dirty and then learn something. We are on that path. Yeah, and how to avoid their pitfalls. Yeah, well, if there is a paper that claims something strange, we also have physicists who check the math, and there were surprises where somebody claimed they have implemented factorization very fast on a few qubits, and then it turned out they had simplified the problem to a level where it just was closer to cheating. Yeah, so one needs, I think, good people and check the facts and have good partners.
Claudia, how are you fact checking or avoiding snake oil?
You mentioned in the beginning with my introduction that we are part of Open QKD and also Pohlink, which are two funding or huge funding projects. And of course, you have a consortia and that's why also a network. Yeah. So of course, you are able to exchange your ideas, your experiences. And this is also a place where you can talk about pitfalls and snake oil. And then, of course, this is a complete new field, so you have to try out a lot, and sometimes it fails. Yeah, so why not tapping into pitfalls? This is not a problem. Yeah, this is good. Yeah, so you have to learn, and you have to try out this new stuff. And I would say it's not about avoiding failures or pitfalls. Like I think Dimitri already said that you have to just start, yeah. So it is necessary that you start this whole trying out with universities, with partners, with hardware companies, and this is always possible to try in let's say trial months. Yeah, so you can start with a bit on D-Wave or an IBM. You can compare that. Yeah, so there are a lot of opportunities, and of course you need time. Yeah, and also first of all you need to get an overview of all the vendors and players in that area. But of course it is growing. Yeah, and I think, of course, there will be pitfalls. You cannot avoid that, I would say. But that's okay.
Thank you. So let's dive a little bit in the time we have into the application side. So we've got a question from the audience if end user applications should be separated from currently available quantum hardware. So the question is, should we build the apps today and then use them in the future? Detlef, what do you think?
So if I understand the question right, would one implement something and run it on a simulator? Maybe that's the idea. Sure, we have to use simulators for now. And the other question is, how much can one be hardware agnostic? So we saw here in the conference a talk from Atos, and who else is providing, or Penny Lane or so, they would try to provide drivers to different hardware. Yeah, I'm not sure yet. I think one has to try both currently. These things that abstract away and good computer scientists, they always try to write software that runs on every hardware, and the hardware guys need to provide hardware that runs every software. I think in quantum computing, we are not there yet. It took a long time for the classical computer. And here, like Claudia also said, this is a very exploratory field, and maybe it's too early.
Maybe some questions also go into that direction. So when applications are being built, is it important to benchmark them against running systems? Claudia, what do you think?
I already said that, yeah, of course. You have to prove that this new technology will be a better technology. Yeah. So of course, first of all, you have to define the baseline. It could be with classical computers, it could be with machine learning methods, and then you have to test that against the new technology, yeah, which whether it is an IBM, an D-Wave, or an free to Anila, yeah. So you should be aware that you always have to prove that this new technology, and I mean not because of the costs, I mean also because of the benefit and the potential, that it is useful to dive deeper in this area, yeah. And not every implementation or not every use case will work, yeah. For instance, we learned in the past 2 years that there are 3 types of, let's say, control points. Yeah. So when you when you think you have found a use case, then you should ask yourself if this is let's say, NP hard problem, so a sufficient problem. Is it recurrent? And the third one, is it a near time problem? Yeah. So do you need the result, let's say real time? Yeah. So, and we explored only when you have 3 points fulfilled, then it could be a use case for quantum computing when it comes to optimization, for instance. Yeah.
Detlef, what are your thoughts on benchmarks?
Yeah, well, the Wolfgang Maurer from Siemens, I think was yesterday or so, said there is no quantum bonus. So that stuck in my mind. I think especially here in this plenum, an end-to-end user perspective, an end-to-end perspective is what we are looking at. And if I look, say, IBM announced for next year a machine with 400 qubits, and in 2 years, one with 1,000 qubits. And in 2019, IBM took this good step to introduce the quantum volume as a metric. And that's already a right direction. But maybe one can go a step further now, and also, like Claudia said, define application level benchmarks that are of shared industry interest. And I see several such efforts are currently underway. And one of them is in the German quantum computing interest group, where now 4 benchmarks have been collected in the area of quantum machine learning, optimization, partial differential equations, and chemistry simulation. And early this summer, they should come out. And I hope such an exercise will also help to define their better things. And we also heard it from Athos today. So I think these are good ways to bring in the user perspective.
So Dimitri, Detlef just mentioned application benchmarks. So if you're building prototypes and they're using current hardware and software, should they be developed further when components of the stack mature, and check the benchmarks and how timeline predictions change or not?
Yeah, so it's very, very important to get to the right application benchmark, and at the same time, it's very, very, very hard because actually we don't have the right hardware to do this right now. So we can't really benchmark yet. We can only define quantum volumes or how many logical qubits a system has. And at the same time, we don't know yet how much time it really takes for those computations. And then at the same time, also the current classical hardware will evolve and become faster. And we don't know how much faster. And there's a lot of new stuff coming up with, light-based computer instead of electric. So things will change. And we need to work together towards these benchmarks. At the same time, with the previous question, to being hardware agnostic. So there's lots of efforts in the fields of becoming hardware agnostic. So you can build, let's say, one piece of code and you can run it on different kind of quantum hardware. And at the same time, then you can do some benchmarking. But I'm seeing lots of efforts into that direction coming up. We're doing that also within our quantum algorithm projects to see if we can really see some advantages and really taking into account that quantum hardware currently is slow and very fragile. So I think those efforts are very, very important, but we should see more of that. But I think what you see is that, it's still very, very in its infancy. And in the coming years, those things will evolve to more mature systems.
Thank you. As our session is ending soon, I want to invite you, the panelists, to share your key takeaways of our discussion on LinkedIn in a short post. And I invite all our listeners to follow you on LinkedIn. Also follow me if you want to. And I want to thank you for being on the panel, sharing your insights, and also the Bitkom for having us.